Alright everyone, welcome to another Java video. In this video, we're going to be solving the CCC J2 question from 2005. It's about RSA numbers. When a credit card number is sent through the internet, it must be protected so that the other people cannot see it. Many web browsers use a protection based on RSA numbers. A number is an RSA number if it has exactly 4 divisors. In other words, there are exactly 4 numbers that are divided into it evenly. Example, 10 is an RSA number because it has exactly 4 divisors of 1, 2, 5, and 10. 12 is not an RSA number because it has too many divisors, 1, 2, 3, 4, 6, 12. 11 is not an RSA number either. There's only one RSA number in between the range of 10 to 12, which was 10, with 11 and 12 being not an RSA number. We're going to write a program that inputs a range of numbers where we're going to input A and B, where A is less than B, and then count how many numbers from that range are RSA numbers. We are allowed to assume that the ranges will be values of less than 1,000. Okay. So our solution breakdown works as follows. We're going to need to figure out how to determine if a single number, if any given number, is a RSA number. So to do that, we're going to have our n be our potential RSA number, and from 1 to n, if a factor is found, we're going to increase the counter. If the counter value is 4, then we have an RSA number. If not, it is not an RSA number, unfortunately. Then by doing this or applying this solution to all the values that we input from A and B, we should be able to figure out which one of them are RSA numbers. So here we go. All right, so let's do our first solution first. Figure out if a single number is an RSA number. So we're just going to have 10. We know that 10 is a value that we know for sure is an RSA number. So let's try to write our code that can help us prove that. So we can say that for divider, int divider is equal to 1, while divider is less than or equal to the num that we're looking at, and divider plus plus. Right, we're going to just check if any of those values from divider of 1 all the way up to num inclusively is a factor. So check if divider is a factor. And if so, we're going to do the following. So we're going to say num modulus divider is equal to 0. Right. Then we're going to have a counter plus plus. This means that you must also now declare a counter. So int counter equal to 0. We haven't found it yet. And after that for loop is over, we can definitely say if counter is equal to 4. Right? We can now output system dot out dot println num is a RSA number, like that, and semicolon. Okay, so that is our solution to our num being an RSA number. So let's run this code. All right, and 10 is an RSA number because we have 1, 2, 5, and 10. Number having 4 different values, therefore it was an 4 different factors, therefore it was an RSA number. But if I were to, let's update it with 12. Nothing prints out because even if I ran this code, we didn't handle a situation where if it wasn't an RSA number, we would have some sort of output. Therefore, there was nothing outputting. Our program seems to be working. Now we're going to do the following. We're going to apply the solution. Apply the solution to all numbers from A and B. I don't know what those A and B are, so we're going to need values. So system out println enter your starting and end values. That, and we can do string input 1 equal to sc.next line. And we're going to copy that over for input number 2. And let's turn them into integers. Int start is equal to integer parse int input 1. Semicolon at the end there, and we're going to copy that over for end and convert that to input number 2. We have our numbers from A and B, and now we're going to need to travel from start to end. So we can say 4, and I'm going to use this value for num, right? Because we are checking for that num. So we're going to say 4 int num equals start, and while num is less than or equal to our end, And we're going to increase num by 1 every time we travel through from here to here. Awesome. Now I'm going to copy this code and then put it inside my outer for loop. There we go. This is an example of a nested for loop, a loop within a loop. Okay. We are now applying, and I don't need this anymore because I have num changing. I'm checking if start is a RSA number, and I'm now checking if start plus 1 is an RSA number and start plus 2 is an RSA number by applying this inner for loop to all the values in the outer for loop that we are generating through our for loop there. Okay, so it's going to start with start. The num is going to be start, and with that num value being applied to this loop here, we're checking is that number RSA number, and we get to determine if not right here. All right, then after that, it goes back up, right? Start becomes a new number, counter gets reset back to 0, and now we get to redo that calculation over again with the new given num value. And we do this over and over and over and over and over again until num is greater than end, okay? But what we need to know is, well, how many RSA numbers we have between input 1 and input 2. So we're going to have an int RSA counter set to 0. Right, and then when this code runs, we're going to output that value, but we're also going to be increasing our RSA counter by 1 here. We found a RSA number. We're going to increase the counter, right? So after this outer for loop is done, then we could say system.out println there are plus RSA counter RSA numbers from start to end, like that. That's our little output of our code. Let's compile. Oops. This should be using double quotation marks. That. Don't make that mistake. Here we go. Run our code. We're going to say from, let's say, 10 to 20. 10 is an RSA number because it has 1, 2, 5, and 10. 14 is a RSA number because that's 1, 2, 7, 14. And 15 is an RSA number because we have 1, 3, 5, 15. So perfect. Those are our RSA numbers between 10 to 20. And we ended up having 3 RSA numbers from 10 to 20. Okay. So awesome. Congrats on writing your first loop within a loop, a nested loop structure in Java. In this question, we were applying this solution to all the numbers that we can generate from our outer for loop. And most often, a loop within a loop is the furthest you will go in terms of nesting. As further you get into your programming career, you might have triple nested loops, but that's usually the maximum amount you want to go, as more nesting of loops creates inefficiencies within your program, and you'll start to see your program slow down its execution. Regardless, great job today, and I hope to see you next time. So stay classy.